Hello students, in this video today we are going to discuss about conditions for a transformation to be canonical, and we are going to solve few problems. So one condition is that exact differential condition So according to this condition, now you see, suppose this is the initial set of coordinate. We need to transform this to capital Q comma P from small q comma P to capital P. Okay, capital Q comma capital P. Okay, so and here in this case, suppose f be the generating function. Now in this case, this transformation from this set of coordinate to this set will be called canonical if small p the small q minus capital P the capital Q is exact differential. So what does it mean? That means this term for this system, small pi d small qi minus summation capital Pi for the whole system, that means this expression must be total derivative of the generating function f. So we know this generating function has four forms. F1, what are the four forms? So small q comma capital Q, it may be function of small q comma capital Q, it may be function of small q comma capital P, and it may be function of small p comma capital Q, or it may be function of small p comma capital P. Okay, so how to find a total derivative of this generating function f? So if let us suppose in this case f is suppose function of small q and capital P. In that case, its total derivative will be del f by del small q into dq plus del f by del capital P into dp. So then this part will be exact differential, and then in this case this transformation will be canonical transformation. Okay, so now our next condition is bilinear invariant condition. So that means if you transform small q comma small p from this set of coordinate to capital Q comma capital P, then if here the bilinear invariant condition, if it satisfies bilinear invariant condition, that condition is expressed as summation from I del small pi dqi minus del qi small qi dpi small pi is equal to, it remains invariant, that means it is equal to after transformation. So del capital Pi d capital Qi minus del Qi d capital Pi. Okay, if this condition is satisfied, then this transformation is also canonical. Now let us solve few problems. Okay, now let me show you how to solve this problem. Here we need to prove this is canonical. Okay, this transformation is canonical. So let me write here the given things. So q is equal to root over 2 small q e to the power a cos small p, then p is given, capital P is equal to again root 2q e to the power minus a sine small p. So here you see, first we are going to obtain this expression p dq minus capital P d capital Q. Okay, so that's why let us find the total derivative of q. That means let us find dq first. So how to find it? Here you see, this is a function of small q and p. Okay, so that's why it's going to be given by del q by del small q dq plus del q by del small p d small p. Okay, so now apply this here, then what you will get, then if you differentiate this with respect to q, then you're going to have twice q to the power minus half, then e to the power a cos small p, then here plus, if you differentiate it with respect to p, then what will you get? You're gonna have, so 2q to the power 1 by 2, so this can be written as 2q whole to the power 1 by 2, then e to the power a, it is constant, then derivative of cos p is minus sine p, so here we can make this sign minus. Okay, so here it will be minus sine p. Okay, so hope you have understood this. So now let's multiply this equation with this. Okay, so here p, this left hand side will be multiplied to left hand side of this, and right hand side will be multiplied to this right hand side. Okay, so if you do so, then what you will get, now you see, in this case if you multiply root 2q and 2q whole to the power minus half, then it's going to be 1, and if you multiply e to the power minus n and e to the power plus a, so then also it's going to be 1, so we will have sine p and cos p only. Okay, sorry, one more thing I have to write here, so here I should write dq. Okay, so let me clean this first, so let me write here dq minus, so here dp. Okay, so hope you understood this. So then, so after multiplication of this p capital P with d capital Q, we have got cos p sine p dq, and here what we're going to have, if you multiply this one and this one, then you will get twice q, and product of sine and sine square, so and product of this and this, that's going to be 1, so here we have only, sorry, sine square p and dp. Okay, so this is our expression. So now so if we subtract from this term, let us subtract small p d small q from this side and the right hand side also, cos p sine small p dq minus 2q sine square small p dp minus p dq. Okay, then what we're gonna have here, so here you can see this is dq and this is dq, so let's take common this part. From here we can take dq common, isn't it? So if you do so, then what are you gonna have, then cos p sine, sorry, okay, sine p minus p dq minus 2q sine square small p dp. Okay, this is what we have got, capital P dq minus small p d small q is equal to this relation we have got now. Okay, Now what we're going to do here? Now here we are going to use two trigonometric identities, and those are 2 sine x cos x. 2 sine x cos x is equal to sine twice x. Okay, and here we are going to use that cos twice x is equal to 1 minus 2 sine square x. Okay, 2 sine square x, so that's going to be equal to 2 sine square x is equal to 1 minus cos twice x. So if you apply these two identity, here you will get 2 sine twice p here instead of x, that's equal to p, and dq here minus, so instead of 2 sine square p, what we're going to write, we're going to write here q 1 minus cos twice x d, sorry, not x here, actually it should be p, twice p, so let me clean it, cos twice p and dp. Okay, so now let me clean this part. So here you see 2 sine twice p dq minus, if you take minus common from this expression, then it's gonna be plus, and if you multiply the q here, then what you will get, q cos twice p minus q, okay, d small p. Okay, so here you see, and this term can be written as there is dq, so we can write del by del q of half sine twice p minus pq dq, sorry, yes, dq. Okay, so that means if you differentiate this with respect to q, then you're gonna have this again. Okay, you may check yourself. Okay, so this part here we can write del by del small p half q sine twice p minus pq d small p. Okay, so if you differentiate it with respect to p, then again you will get this. So here you see we have got these two terms, same, these two expressions. So this is also function of small p and q, and this is also function of small p and q. Okay, so here this is the generating function in this case, and you can write this here you see this is in this form. So if you consider that in this case f is equal to, which is a function of small p and q, is equal to half sine twice p minus p, if you consider this, then you can write this result as del f by del q dq plus del f by del p. So let me write clearly. Okay, del f by del small p dp, so which is nothing but the total derivative of f. So that means if it is equal to, this expression is equal to del f, that means it is exact differential. Okay, so where f is equal to this one, this is the generative function, is exact differential. Therefore the given transformation is canonical. Okay, so that's how we can solve. So let me show you another example. So now here, so we are going to show that this transformation is canonical. So let me show you how to solve. First let us write the given things. Okay, so here capital P is equal to half of small p square plus q square, this is suppose equation number 1, and capital Q. So capital Q, that is equal to tan inverse small p by small q by small p. So which implies tan capital Q, tan of capital Q is equal to q by small p. So and tan q can be written as sine capital Q by cos capital Q, and let it be, so let me write here. Okay, sine capital Q by cos capital Q. So let us suppose this is x. Okay, let us suppose this is x. So from this relation, what we can write? We can write that small q in this case is equal to x sine capital Q, and small p is equal to x cos capital Q. So hope you have understood this. So let us obtain small p square plus small q square, that's going to be x square. Okay, from this relation, squaring and adding these two, we have got this relation. This is suppose equation number 2. Okay, now using 2 in 1, if you use 2 in, then it gives capital P is equal to half x square. Okay, half x square. So here we have put x square. Okay, and that implies x is equal to root over 2 capital P. Okay, if you use this value of x here and here, then you will get small p and small q. This small q is equal to 2 capital P sine capital Q, and small p is equal to root 2 capital P cos capital Q. Okay, so we have got these two relations. Then here what we're going to do, let us find dq. Okay, so then dq, so here it is function of capital P and capital Q, so we can obtain del small q by del capital P dp, and plus del small q by del capital Q dq. And if you do so, then what will be our result? So then we will get dq is equal to root over 2 capital P cos capital Q dq minus, plus twice p whole to the power minus half sine q dp. Okay, so now let's multiply this equation with this relation. Okay, so this p will be multiplied here, and this right hand side will be multiplied to this right hand side. Okay, so why we are doing this? In order to get this small p d small q. Okay, so in order to obtain this. Okay, then we will subtract capital P capital dq from both sides. Okay, so let's multiply it here, and this is multiplied to this. Then what we're gonna have, then we will get small p d small q is equal to 2p, here it should be capital P. If you multiply this one with this, then you will get 2 capital P, then cos q and cos q, that's going to be cos square q d capital Q plus, and if you multiply this one with this, then it's going to be 1, and we will get cos capital Q sine capital Q d capital P. Okay, so again what we are going to do in this case, we are going to subtract from this side capital P dq, and hence from the other side as well, to capital P cos square capital Q dq plus cos capital Q sin Q d capital P minus capital P dq. Okay, so here what we can do, this capital dq, capital d capital Q can taken common, can be taken common, and doing so what we will get, then we will get 2p cos square Q minus p. So one more thing, we can take p also common. Okay, so we can take p also common, so let me write it this way. So 2 cos square Q minus 1 capital P dq, then plus this remaining expression cos capital Q, so let me write cos capital Q sin capital Q d capital P. Okay, so here you see, so we know 2 cos square Q minus 1, that is nothing but cos 2q. Okay, so here we have used a trigonometric identity. Okay, so then the right here capital P and dq, then plus, and here you see from this, here we are going to use this identity, that sin x cos x is equal to half of sin twice x. Okay, so if you use that, then you will get 2 sin twice capital Q d capital P. Okay, d capital P. So here this part can be written as del capital Q, here it is dq, isn't it? So del capital Q of half P sin twice Q the capital Q, and it can be written as plus del by del capital P half of capital P sin 2 capital Q d capital P. Okay, if you differentiate it, again you will get this one, and if you differentiate it with respect to Q, then again you will get this one. So if you differentiate this with respect to P, then we are going to have this result. Okay, so now you see, if you see these two terms, these are nothing but functions of capital P and capital Q. Okay, and both are same, so this is also a function of capital P comma capital Q, function of capital P and Q. Okay, so we can consider this one as generating function. So this results del f by del capital Q dq plus del f by del P dP, so which is nothing but df, which is exact differential, and hence therefore the given transformation is canonical. and here f is equal to half capital P sine twice capital Q. So hope you have understood this. So that's how we can solve such kind of problem. So hope you have understood, and if you like this video, please share with your friends and subscribe the channel. Thank you for watching.